Well, it is time for WeatherBrains. This is WeatherBrains episode number 643. It's the pre-show. You know what this is. It is a marvelous, magical time where we do three things. We share boring personal stories, humorous anecdotes, and we occasionally say outrageous things. So this is Monday, May 14th, and got a few folks off tonight. We know Aubrey's had some weather issues today. She is off. Let's see. Kevin is out. Rick Smith is out. He's got kind of a dual combination of severe weather and a band concert with his kids. Who else is out? Nate. Nate is at 50 Cent Beer Night at Pub 261. But Brian, we have you and me.
Whoopee.
Is that a new? What do you mean? You sound so down. This could be the greatest ever. Is that a new shirt you're wearing there, Brian?
No.
Is that one of those Duck Creek Festival shirts?
The Buck
Creek.
Buck Creek.
The duck is our mascot. Buck Creek Festival was this weekend, and I just went to the city council meeting to present our 4 $500 scholarships.
Well, how did you raise that money? I thought it was free admission.
It is.
Sponsors.
Sponsors, and we have the adult beverage concession.
Oh,
there you go. That's it. And now they're going to have they're going to have betting on sports next year.
Yeah, they'd be like the casino over there.
Yeah, it's like the Atlantic City of the Southeast.
Yeah, you know what clobbered us Friday night?
What?
The ATM machine went down.
Oh my goodness! Yeah, that's never good.
So Brian had to go cash one of his big government retirement checks and hand out cash out there on site.
Oh yes, right.
You could have just dug up a couple of those jars out of the backyard, Brian, and been fine.
So one of our main anchor guys went down there Saturday, and Brian put him in that.
He was our celebrity duck wrangler.
So did he get flesh-eating bacteria? Yeah.
No flesh-eating bacteria. He was still alive when we let him go.
I'm not so sure what kind of sewage they put in that creek upstream. I mean, it's just not so sure I'd want to be in there. But no. So I was going to go do a live shot, and they said that they couldn't get a shot out. We have a brand new satellite truck here,
and nobody knows how to run it yet.
Well, they're not allowed to use it yet for some reason. So, but you can't get a microwave shot out of this pit we're in down there, and you can't do the cell phone live view because of the latency. When like the graphics don't match what I'm saying. So,
well, we did the live view, and I chatted with you a couple of times.
No, you did great. It was you were working that hat, man. Kim, how are you? Welcome.
Thank you. I'm doing really well this evening. How about you all?
Good.
Fabulous.
Deep breaths.
Just had a pizza, part of a pizza.
Nice.
Ragtime Cafe, which is our little next door cafe here. So I'm good.
That's the James Spann spotting place, isn't it?
That's every Monday night before WeatherBrains. I go down there. It's just kind of a tradition because I can't go home.
Yeah.
It's just I just can't go home. So we go down to Ragtime and have a little time together. So there you go.
Awesome.
Look what I dug out of the attic right here, James. My Atlanta Braves shirt. Thank you very much. It's been a while since you could wear that.
Hang on. I got to connect my headphones. The headphones went back over to this telephone here. Bluetooth, please don't go out.
Please guests show up on the Hangout.
Oh, Bluetooth.
We're just full of prayers tonight here.
All right, they're back. So what are you doing? The Atlanta Braves thing? Is that what that shirt is? Or
yeah,
Alabama?
19 and 12. How about that? 19 and 12.
Oh.
Stolen from the Florida State Seminoles.
I think y'all stole it from us.
No.
When was that chant started? 1935, Brian?
1857.
Oh, yeah.
Back when it was a girls' school.
Was that your freshman year? Oh, no, that's right. It wasn't co-ed yet, was it?
I couldn't go then.
Oh, my goodness. I remember when they played Alabama almost to a tie in Birmingham. It was like 6-3 or something on a Bucky Berry field goal in 1974.
Yeah, that was something else, wasn't it?
0-300.
Mm.
I think the coaching staff of Florida State tore up the press box at Alabama because they were so mad that they didn't win, and they had to send them a bill.
That's got to have been a close game. Football brains are us.
Yeah, it's going to be that time of year start thinking about football.
What a beautiful
Not
time.
yet. I just barely thinking about hurricane season.
You
thinking about football season. Yeah,
you might be thinking about Alberto here.
I'm telling you, man, the school starts in August, first week in August. I mean, trust me, football will be here before you know it.
You got it.
Yep.
Mm-hmm.
Wow, bunch of images from Washington, D.C. I don't think there was any damage up there, though, from what I can tell. It was a pretty nasty line of storms that came through.
So what happened to spring severe weather in central Alabama?
Right, or here.
If you blinked, you missed it.
Did you see the Ring of Fire? The Ring of Fire set up on the day one convective outlook?
Yeah.
It's the Ring of Fire. I mean, it's a little early for the Ring of Fire.
Really uh-oh. What? That's never a good sign when the guest calls. I shall mute thee and be right back.
Is it like a 1940s telephone that Bill has there? I mean, wow.
Hello.
Yeah. All right, so I think my Bluetooth radio is going out on this laptop. This thing has been a marvelous computer. I've had it for a long time. Okay, it's back now because I'm run these headsets that are Bluetooth, and I run this trackpad which is Bluetooth. There might be interference because I've got a computer, in that thing in front of me that uses Bluetooth with another trackpad and a keyboard. Got 2 iPads in here and a phone all running Bluetooth. I bet it's interference.
I bet it is too.
Yep.
It gets confused.
I do not want to get another computer. I want to run this forever.
I can't believe how long mine's been going.
I've never had a laptop for this long. I bought this in early 2012, so it's over 6 years old. And I bought the first one with a solid state drive. That was the key. That was the huge game changer, was the solid state drive, and maxed it out at 16 gigs of memory, which at the time was all you could get.
Yeah.
And the solid state drive is only 500 gigs, external little USB drive for all the video files and stuff. So it's just been it's like my little companion here. We've been together for so long. I don't want it to go away. And now they say the new keyboards are just bad or crappy.
Yeah.
The new MacBooks. Apparently there's some class action lawsuit people filed today.
Really? What's wrong with them?
They don't work.
Apparently, they're not reliable. Yeah, they're not reliable. And if you get a speck of dirt or dust under a key, it stops working, and they have to go in and do major surgery. And sometimes some of the allegations, it makes odd noises. But anyway, it's.
And how do you keep dirt out of a keyboard?
Right? That's impossible. That's an impossible standard.
I guarantee you, I would not even want to see the gunk that is in this under these keys. I don't even want to know because I know, I just know it's bad. And I've only got one key's kind of flaky. The little up arrow key's kind of flaky, but all the other ones work fine. I do notice one's got part of the black has actually come off. It's just been beat down to a pulp because I'm a heavy typer. I bang on these suckers.
Yeah, me too.
It's the keyboard.
The one thing I don't know if this is good or not. I've gotten so used to autocorrect that I just think that's dangerous.
Very much so.
Like Chrome, the Chrome browser on a Mac, you don't get autocorrect. That's the main reason I use Safari, because you get the autocorrect from the operating system. When I'm typing on something that doesn't have autocorrect, it is just a mishmash of misspelled words, and it's a nightmare. So.
Okay.
We have some guests.
His wife got it working for him.
Great.
I think that's wonderful.
That does appear to be what has happened. It's really delightful.
It isn't the way it works around my household.
Can't imagine.
Oh, goodness.
One of the most
on Monday.
One of the keyest
my fresh day.
One of the keyest words you hear around my house is I didn't do anything to it.
Not my fault. I didn't touch it.
Yeah. Well, I love my wife. We've been married a very long time. It's all her.
That's wonderful. My husband is likewise responsible for setting up all of our technology, and he even has everything wired to the point where I should be able to just press 1 or 2 buttons to make everything work, and I still have to ask him which one of the buttons, and he just looks at me like, I have made this literally as easy as I can for you. Just not my skill set. Just not my skill set.
The remote control for our TV and our UVerse service is a real conundrum. It really is, because you can accidentally hit a button and you don't even know what you did. And it you know, the TV goes off on these crazy, and you don't, sometimes I have to figure out how to get it back, and it's really difficult. Oh, well.
Poor
Yeah. The challenges of modern living. We could write a book. There's so many challenges.
Very big book.
Let's check on John. John, can you hear us?
Yeah, I can hear you.
All right, we hear you fine too. That's great. So we're in good shape. We'll get started.
And John even looks like his picture. It's always a good sign.
Not in the witness protection program or anything.
All right. We have
Wait,
to
no
wait
television here.
2 more minutes for the TV side to join us, and we'll get this party started here. A lot of folks are out. By the way, I've got... Uh-oh.
Say that again, John?
Looks like you're an Atlanta Braves fan.
I pulled it out of the closet because we're 19-12. Thank you. Wow.
Yeah, I followed them when they were the Milwaukee Braves.
Oh my goodness.
Yeah, Milwaukee
Henry
Braves.
Aaron, 1957 world champs, huh?
A lot of enemies in Milwaukee.
No, that's true. But they got the Brew Crew now.
I saw Aaron play at the old stadium in Atlanta.
I saw Aaron play at Rickwood Field in Birmingham against the Baltimore Orioles in 1975 in an exhibition game.
Wow, cool.
Probably my favorite baseball game in history, because Brooks Robinson, Aaron, Necro, no telling how many Hall of Famers were there. Who else would have been a Hall of Famer on the Orioles? You know, all those incredible pitchers, you know, Palmer and Quayle.
Yeah.
And, you know, that was just incredible. Dusty Baker.
Right.
That was a break.
We are almost ready here. No, I've been to a game at hello, good evening. Welcome to our television audience. This is WeatherBrains, about to start the show here. It's Monday night, 30 after the hour. You know what happens here. I'm always shocked at the number of emails I get from people that watch the television. I keep forgetting we're actually on television. But many people watch, and we're glad you're here. And you know the deal. This is not part of the produced podcast. That begins here in a couple of minutes.
We're preempting the Warriors and the
we're sharing. Yeah, exactly. We're sharing boring personal stories. So, you know, that old place where the Braves used to play was called Atlanta Fulton County Stadium.
Yeah.
Right. And I went there for an NFL Falcons game. This was a Monday night game back in probably 77 or 78, and Howard Cosell was hitting on the girlfriend of one of my friends. Now, understand, we were like 20 years old, and Cosell was probably in his 50s at that point. And my friend almost punched him out. That would have been some great entertainment.
Yes, it would have.
All right, let's get these recorders going here.
Too bad we didn't have the Me Too movement then. Huh?
Yeah. But Howard Cosell did Monday Night Football with Dandy Don.
Yeah.
And
is Cosell still alive?
I don't think so. Here we go. We were recording, and let's start this sucker in 5, 4, 3, 2, 1. Hey, this is WeatherBrains, episode number 643. This is for May 14th, 2018. This is the show that's all about weather and occasionally some related topics. Thanks for joining us this evening. Considering the time of year, we have a lot of folks out this week. We know that Rick Smith, I think, has his one of his kids. They have a band concert tonight. It's almost graduation time. I mean, this is that time of the year. We've got Kevin, who is out mysteriously. He never tells us why anymore. We've got Nate Johnson, who is out. He says he's going to join us next week from Boston. You know, Nate travels all over the country working for NBC. Aubrey is out. Aubrey's had a rough weather day in Harrisonburg, a nasty line of storms coming through there earlier today. But the troopers are here. And Kim, goodness gracious, thank you for giving us your time. You're busy. You're important, and we are honored that you're here. Thank you.
It's really sweet. I'm really grateful always to be able to be here. And I have to apologize. I didn't give you a reason I wasn't here last week. And it was simply that I came home from the first day of hazardous weather testbed experiments and went to sleep and woke up at 9 p.m. and told my husband, "Oh, why didn't you wake me up?" So I'm so sorry to have missed you guys. But yeah, there are other fun things happening with some of our brains. We have test bed stuff going on at the lab. So it's that season for us too. Just a really fun time for everybody right now, I think.
So did the little paupers like us ever get a chance to have fun with you guys?
Paupers like you, have you not received our invitation to be part of our broadcast meteorologist experiment?
I did.
Yes, you did.
No, I did. And I, you know, the problem we have, May is a ratings month in the television world. And basically they will, if you are dead, they will prop you up out there in that green wall and just kind of make your arms move automatically. So getting off during a ratings month, especially May and November and February. There's a ratings book in July that's not that important. It's summer and you get a lot of anomalies there. But no, the Christmas rates are based on the May ratings, the fourth quarter rates. So this is kind of a big deal. So but one of these days, Kim, I would love to come out because that sounds like a ton of fun and a great way to learn too.
Yeah, you get to see all of the new products as they're in development. You actually get to help to create and steer the direction those products end up taking. This year, we ended up doing the broadcast portion of the work in June. I don't know if June is a little bit better of a month for you guys typically, but we'll be trying to do the same thing again next year, either June or maybe the fall to join another experiment. So keep your eyes peeled. We would love to have you.
I would love to do that. Now, Bill's got me coming out to some party in St. Louis. Bill, explain this party you want me to come to. Now, this is the NWA pre-show, right? It's kind of like the pre-show for the WeatherBrains here.
Well, this is the Weather Ready Fest, which is the public outreach event. It'll be on Saturday, August 25th from 9:30 to 5, and we're expecting about 85 exhibitors. We've already raised over $35,000 for the foundation. And we're going to have activities, fun, games, stage shows. It's going to be crazy. Expecting 9,500 people to attend that day. So it's going to be huge. We're going to have, you know, big equipment, going to have storm shelter stuff. It's the Weather Service is heavily involved. The local emergency manager is just out of this world. All the TV stations are playing. It's going to be a huge event. The Cardinals, Fred Bird will be there. It's going to be an incredible day.
Okay. Well, Brian, are you going to go to this party in St. Louis? What's your status?
Probably not because you're going.
That's part of the problem. It's like we all can't have a hard time getting away at the same time because somebody has to man the battle stations in here.
Maybe just our luck that with the NWA and you gone, we'll have a hurricane. That will be
that's exactly what happens. And you know that's going to happen. I got a bad feeling about this hurricane season, but we'll see. But anyway, Brian, you just had your big Buck Creek Festival party that you do every year in May. So
yes,
weather was good.
It's a little family-friendly event on Friday evening and then an all-day Saturday. It was fabulous. The weather was superb, a little warm and a bit dry. I've had 18 straight days now with no rain. So looking forward to this weak tropical, non-tropical, whatever system off the west coast of Florida that could bring us some soaking rains. They'll be beneficial.
Yeah.
I'm afraid it's just
Talk
going
about
to tease
that.
us. I'm afraid it's not going to be a big deal for us. I hope we get some
well,
rain out of it.
So Bill just said it's not going to rain. Brian says it is going to rain. This is going to be awesome. Who's going to be the winner? As always, the truth is probably somewhere in between. But Bill, let's bring in our guest here before he hangs up on. We'll do weather roundup, talk about the Gulf disturbance and much more shortly. But let's bring in our very important guest.
Yeah, James, I'm really excited tonight. Our guest WeatherBrain is a research meteorologist at National Severe Storms Laboratory, visiting professor of atmospheric science at the Desert Research Institute and the University of Nevada, Reno. He joins us tonight from his daughter's home in Sacramento. John Lewis, welcome to the show.
Glad to be here.
And you're the author of this book from AMS Books. You know, I'd always heard of Werner Sumi, but didn't know very much about him. So we're going to learn a lot about his life and work tonight. But first, tell us about you, John.
Well, I started in meteorology in 1961, so I've been in the business well over 50 years. Came in when the prediction model was a barotropic model, making forecasts about 3 or 4 days, basically following long waves in the atmosphere. Had facsimile maps in the various departments around the country. But we didn't really get into what I would call weather until probably about 1965, when we got what we call a baroclinic model. But the thing I tell people is, when I first started to look at the weather products that came out of National Meteorological Center, it was pretty tough to make a 2-day rain forecast any place in the United States. And now, with our excellent weather centers around the world, in some situations, we can make very good rain forecasts for relatively small locations. I would say 5 to 10 days. Depending on the weather regime, sometimes we can make a fairly good forecast at 10 days. Typically, we do very good at 5 days. So I look at my career as one that has spanned this great number of years with numerical weather prediction. And we just started out very modestly with a product that we couldn't hardly believe the rain forecast to the day now, where every city, depending on what you're planning for the next weekend, people believe the weather forecast. So it's been a wonderful experience for me to be in the business for these many years and see the products advances. And whether we'll ever get to seasonal forecasts, I would say that's questionable. Maybe warmer, colder than normal, wetter, drier. We're doing a little better on that. But a detailed forecast out to 30 days or something, none of us are going to live long enough to see anything close to that. But it's been a great advance in the years that I've been in meteorology.
That's an amazing time to have been studying this science, for sure. You've seen a lot happen. Take us through your career trajectory, John.
Well,
talk about your resume.
But my goals as a young man, grew up in apricot orchards of the Great Valley of California. Didn't really see what I would call severe weather until I went away to Chicago for meteorological training. But I grew up in the orchards of California. And I would say my major interest in geophysical science came in our vacations, which we took for maybe 1 to 2 weeks a year, traveling from someplace near Sacramento out to Santa Cruz, Monterey area, June, July, summertime. And I just became fascinated with oceanography. And I became especially puzzled with the inability of any weather people to forecast fog or stratus in that area, which is the primary weather event of the mid-California coastline. And so I just started to think about it and basically said, that's something I really want to figure out. How do you forecast sea fog? That was, I would say, my first interest in geophysical science. And my goal upon graduating from high school was just to be a high school math and geometry teacher, and went to the State Teachers College about a mile from my apricot orchard, and did very well in a teacher's college. And when I graduated in 1961, you'll remember that John Kennedy was our president, and there just became this worldwide interest in space and space science. And he basically said, let's use space science for peaceful means, trying to bring Russia and the United States together as well as the other countries. And what I noticed on my senior year at Sacramento State College was just this flood of opportunities in geophysical science around the United States. And so I said, you know, I still want to be a teacher, but, you know, I want to explore this geophysical science. And so I applied to University of Washington in Seattle and University of Chicago, and accepted at both places. But I got a tremendous fellowship from the University of Chicago, a full ride from Ford Foundation, everything paid for. And I just said, you know, I'd kind of like to stay on the West Coast, but I'm going to Chicago. And that's where I got my introduction. I basically took geophysical science, a lot of oceanography, a lot of meteorology. And at the end of the 2 years, I basically said, I got to get out and do some work. I'm just a little tired of academia. And I told my professor, Dr. George Plossman, I said, you know, I appreciate you having me stay on here to get my PhD. But I just said, I need to get out and do some work. And he said, what are you going to do? And I said, well, I'll probably go back to California and maybe teach in junior college. And he said, well, he said, can you hold on a minute? I'm going to make a phone call. And I said, sure. Well, he's not talking on the telephone. Somebody by the name of Walters on the other end saying this, that. He's talking about me as a qualified student. Is there a job down there for somebody who really is good in mathematics and weather prediction and doesn't want to go to school but just work on a research project? Well, he hung up the phone. He said, if you want it, John, he said, I've just got a job for you at the University of Oklahoma in Norman, Oklahoma. And I said, geez, I said, what do I know about Oklahoma? I said, all I know is Bud Wilkinson, and he's got a record of 57-8. And I said, I really like football. And I told Dr. Plossman, I said, you know, that sounds like a pretty good idea. I said, well, I got it all set up. All you got to do is take a ride down there. I got a friend that's going down there. Take a ride and see if they like you and whatever. Well, lo and behold, they liked me, and I got full-fledged into severe storm meteorology. And that's where I've been now for about the last 50 years. So that's kind of what I would say a pathway through the various places. But I just found the science of meteorology so wonderfully demanding. And I basically worked under the premier, I'd say, mathematical physicist, weather prediction person in the United States in the last half of the 20th century. And that's Professor Yoshikazu Sasaki, who basically was the founder of all the data assimilation methods that are used around the world now. And he basically got me into that pathway. And so I've stayed there now for 50 years and published 2 books now in data assimilation, working on the 3rd. And at the same time, I just really had a strong interest in the history of science. So I took some courses in history of science and came under the tutelage of Dwayne Roller, a world-renowned historian of science at the University of Oklahoma. And so since about the early 80s, I've written quite a few papers on the history of meteorology and oceanography. And the University of Wisconsin came to me in 2009 and they said, John, would you consider writing a book about our favorite son, Werner Suomi? And I said, you know, I got a lot of other work to do in my research, meteorology at National Severe Storms Lab. I said, I don't really have the time to probably write an entire biography. But I said, if you could pull some people together to really help me, some great archivists and librarians, and they said, we'll do it. And that's what happened. So I don't take full credit for this story. I actually had 6 co-authors. 3 of them were proteges of Vern Suomi. I would say the most valuable person was a woman by the name of Jean Phillips. She's an archivist and the world's expert on Vern Suomi. And so I really wanted her name to be up front, but they all forced me to take the lead position because it was my single voice writing of the book, but I could not have written it without the help of these other 6 people.
Well, that's outstanding. But, you know, we all have heard of Sumi, but we really don't appreciate him for all the things that he did, John. Talk about him, you know, in a capsule for a moment before we kind of dig into his life.
Well, he was a beautiful combination of engineer, physicist, and meteorologist. And he had no ideas at all as a young man growing up on the Mesabi Range in northeast Minnesota, the Iron Range. He grew up there during the Depression. He basically just was an excellent student in all the crafts and trade classes at those wonderful high schools. The iron ore companies put much money into the high schools. They had the best trade shops in the world, and he excelled in those shops. And it looked like he was going to end up being maybe some kind of a technician at one of the big iron ore mines. But his brother, older brother, he came from a family of 7. His older brother basically had to take over for the family because their father became very ill and had to drop out of his work in the mines. The brother took over the family care, and he saw in Werner a wonderful talent in what he would call engineering principles. And he basically said, Vern, if you earn the first $14 this summer for tuition at the Eveleth Junior College, I'm going to pay your way through junior college. And Vern Sumi worked, got his $14, went to the junior college, did very well, worked at the CCC camp during the 1930s and the Depression, came under the influence of a very powerful politician later in Minnesota. And this man saw Vern's talent, and he said, I have connections with Winona State Teachers College in southeast Minnesota. I'm going to find a scholarship for you. And in effect, he escaped the mines, which very, very, very few people ever did in the 1930s. And so he came into a college career, got a degree in teaching, was teaching in Minnesota when the war, 1940, looked like it was going to occur. And he heard a program from the University of Chicago. Carl Gustav Brosby was trying to get young college graduates to come in to learn forecasting as part of the Air Force and the Second World War. And Sumi said to me, I worked for him and talked to him much. He said, you know, they were breathing down my neck. I didn't want to go into the infantry. I was married. He said this was a way for me to do some scientific work. So he jumped out of teaching, went to the cadet program at the University of Chicago, and basically learned meteorology. But the long and the short of it is he stayed there and taught during the war. And after the war, one of his college graduate classmates started a program at the University of Wisconsin, knew of this man's great talent, especially in experimental work, and begged him to come to University of Wisconsin as a professor. And that's where he then went from the University of Chicago to Wisconsin. And that was the late 40s. He got into the interest in satellite meteorology in the 1950s, basically got into the IGY, got an instrument up on an IGY satellite, made the first measurements of the heat budget of the atmosphere in 1959, and he basically then became the glorious leader of satellite meteorology, and he stayed in that position till his death in 1995.
That's an amazing story. But being a pilot had some role in that cadet program, didn't it, John?
What did you say, Bill?
He was a pilot, wasn't he?
No, he was not a pilot. He got a civilian aviation agency license to fly, but he never flew for the military in either the Navy or the Air Force. He basically stayed there as a teacher at the University of Chicago.
So he was interested in flying, though, and that had some...
Very interested in flying, and he also told me, he said, when I was accepted at the University of Chicago, he said, I had no interest in becoming a meteorologist. I wanted to be an engineer. And at that point in time, I was trying to escape being in the infantry in World War II. So from a very inauspicious beginning, I would say of all the people I've ever studied in the history of science, his training in what I would call the practical arts of electrical engineering, just a technician in mechanical projects, then getting the meteorology, and what happens in the early 50s, as some of us who are older remember, the space age, Wernher von Braun, rocketry, and with the IGY starting in 1957, there was a need to make measurements of weather from space. And he was the premier person to do it. And that set him on a track that was unbelievable. And I would say the spirit of the times, which was satellite meteorology, satellite instruments on board satellites, with his interest in designing instruments, understanding the theory of weather, they just meshed in some unbelievable way. And I've never seen a person in physics, chemistry, any of the sciences, whose background melded with the spirit of the times so majestically as his did, because he had no great aims at becoming some great scientist. He truly didn't. I think he was going to be satisfied to be a professor at the University of Wisconsin, but his ability, his timing, the IGY, things came together in a majestic way, and he then, I think, had a whole new view. And I always thought to myself, how old was he when he made this great advance in understanding of measurements from space? He was a professor. He didn't have tenure yet. He was 44 years old. And so his career really started when he was in the mid to late 40s. And then I always wanted to talk to his wife about it. He had 3 children, very devoted husband and father. And I just wanted to ask her, when he catapulted into this other place in satellite meteorology, did your husband become a different person? And I'm pretty sure he had to, but they were very devoted to each other. I knew both of them very well. And I would just say it's kind of a Horatio Alger story. Somebody who started very lowly, but somehow came into the focus with his background interest and then unbelievably hard work to then catapult himself into this field. And look at satellite meteorology today. I mean, we're trying to make longer range forecasts. 70% of the Earth is covered with an ocean. We don't have radiosondes there. We don't have stations there. We are working at a Mad Hatter pace to even get better satellite observations. And I'll tell you, Space Science and Engineering Center at University of Wisconsin, where I worked with Vern, is an unbelievably active, energetic, exciting place to work. And that's the way it was when he founded that institute in 1967. It's just everybody who works there, who's ever worked there, say, this is the greatest place to work. I can't wait to get to work today, not only for my project, but find out what everybody else is doing on all the 12 floors of space science and engineering. So the man had an ability to draw people who he trusted, and most of them were physicists, PhD physicists is who he really liked to work with. He brought them in, and then he let them alone. You do this. And that was his great talent, identifying the people, setting them on a trail, and then taking his hands off and seeing them. And I've known so many of those people, and they are just truly great scientists working in a great environment. And I'm sure Vern Sumi had success with that institute far beyond his ever realizations.
So John, talk about Rossby for a second. Tell us about who he was and how he was a mentor to Vern.
Well, Carl Rossby, of course, to all who knew him, and I did not. He died in 57. I started at Chicago in 61. But the good thing, all the professors I had at University of Chicago were proteges of Carl Rossby. And so I learned about Rossby secondhand, but very detailed information. And Rossby, I wrote a paper on Rossby in 1992, and I talked to about 20 of his proteges who were still alive. And what I came away with was a great theoretical thinking person. He wasn't especially good weather forecaster. He nevertheless was interested in the upper air, and that's the major contributions he made from the late 30s into the 40s, understanding the long waves and their traveling in the atmosphere. But he had an ability to just excite people about weather. He traveled around, talked, and then drew excellent people into the University of Chicago, actually to MIT before he came to Chicago. And what my professor, George Plotson, told me, and he knew him well, he said he could entrain you into his interest. And you didn't realize it until you had been around him, but you got so excited about what he was doing. And then he had power in the, I would say, the warehouses of money in the United States with all of the funding and so forth. He got a lot of money from the Navy when NSF came in, got a lot of money there. So he had monies to basically promote his programs. He became very disappointed at the University of Chicago for the following World War II, because he said, I want an international institute. And even though the war has just ended, and there were a lot of meteorologists in the Axis countries, Germany, Japan, Italy, he said, I want an institute where I can invite all of these people from these different cultures and these different countries. And the University of Chicago said, this is not the time to do that, Professor Rossby. And he said, well, then I will be leaving. And he left in 1948, and he introduced the International Institute at Stockholm in Sweden. And then he invited people from the entire world. And again, he had started the program at Chicago, but it shifted to, he basically, where he went was where the center of activity in meteorology was. I wish I could have known him. I knew him vicariously through the professors who taught me at Chicago. But he truly was a man with vision and an ability to attract. And this is what Vern Summy got from him. I pushed that point in the book. None of the other proteges of Carl Gustav Rossby, 20 of them who I interviewed, none of them gained the power of pulling money, people, and ideas together and get started on monumental projects well before others did. And that's what Summy brought away from the University of Chicago.
So talk about some of those early field research projects that Summy was involved in upper air with Rossby, Piebles and early soundings and things like that.
Well, at Chicago, as a student in the cadet program, he told me, John, I became the master of radiosonde repair. And at that time, when upper air observations were not really being made around the world, they didn't start really till the late 40s. Nevertheless, upper air soundings were being made in Germany and in the United States. And those were very expensive items, and they were flown in the United States. Farmers would collect them after they fell, little notice on them, send them back to the University of Chicago. And that's where Vern became the expert at fixing them. And then they were used to train the meteorologists at the various schools around the United States. There was 5 schools in the cadet program: Caltech, MIT, University of Chicago, UCLA, and the military training in Grand Rapids, Michigan. So they trained 7,000 forecasters in 5 years. 7,000, and that is where the body of people in meteorology who brought it forward after the war, they were those who were trained in those 5 institutions. And Summy captured the majesty of Rossby, his vision, identifying problems. I would say Vern was like some of the great scientists in the history of science who would choose a project and never give it up, decade after decade after decade. And his major project was studying the heat balance of the Earth's atmosphere that he started in 1959, and he was doing it in 1995. And he did it not only on the Earth, but he did it on the other planets in our solar system, Venus, Jupiter, Mars. He was involved in doing heat balances on those other planets. So he had a vision that I say would take him beyond the typical meteorology and became a world-renowned force to direct science. And as far as I know, he's the only geophysicist, let alone the only meteorologist, who ever won the National Medal of Science, which he won in 1977, given to him by Jimmy Carter, I believe was the president at that time.
So John, he had an interest in agricultural meteorology. So he almost ended up at Iowa State. How did he end up at Wisconsin?
Well, he developed several instruments as a graduate student and teacher at the University of Chicago. One of them was a sonic anemometer. He developed the first sonic anemometer. How does a sonic anemometer work? It puts out sound pulses, and depending on the wind direction, the sound can either travel faster with the wind or less fast against the wind. That's the principle of it. How do you get it to work? He and two other of his fellow students there developed the first sonic anemometer. It was very useful in the canopy of agricultural fields. And so ISU, Illinois, Iowa State University was so advanced in doing studies of especially corn. And they said, could you come and demonstrate your sonic anemometer and other instruments over our canopy? He went there. They wanted to hire him right away. They said, you have a faculty position, bring your sonic anemometer, whatever. What did he have at that time? He had a bachelor's degree from Winona State College. He didn't even have a master's degree by going through the University of Chicago. They wanted him as a professor. He came back to Chicago, and he said, the same week I went to Iowa, I got a letter from Wisconsin, and Reed Bryson, my fellow classmate from the early 40s, who had just started the meteorology department, he said he wanted me in the worst way to come to Wisconsin. So he said, here I was, offer from Iowa State, $5,500 a year. Wisconsin, $5,000 a year. He went to one of his friends who was working on the thunderstorm project at the University of Chicago. He said, you're from Iowa. He said, when people in Iowa go on vacation, where do they go? And he said, they all go to Wisconsin. Story ended. He accepted the job at the University of Wisconsin in 1947.
That's great.
But working for him, I worked with him. I would say his real talent was to encourage you. And when I came there in the early 80s, he would stop by my little area of study. I was in what they called the war room with all the big computers, all the satellite data. And he would just come up in a very casual way. And he'd say, what are you working on, Tom? What are you working on? And I would say, you know, I'm trying to use this VAS data, Visitor Atmospheric Sounder data, that puts out these upper air geopotential fields every 3 hours to see if I can get a better idea of how these storms develop instead of just using the upper air soundings every 12 hours from the radiosondes. And he said, give a seminar on it, would you, John? I said, sure. He said, next week, Tuesday. Here I am. I filled up 3 blackboards with my ideas that were really ideas that I developed in graduate school with Professor Sasaki. And it went over very well. And Vern came to me the next day. He said, I want you to lead our project in assimilating all of this visitor atmospheric sounding data and getting it into the models. And so he just had this way of encouraging you. And he later on, I remember him coming by, talking about various things in the Institute. And he said, you know, John, this stuff is so hard. He said, we have to encourage. We cannot discourage. And so that became a philosophy that I adopted in my own career, that don't discourage, whether you're reviewing somebody's paper, look for the good things, encourage that person. try to help them in some of the things that look weak. And that's the way he always did things. He demanded a lot from you. He never let you off the hook. How are you coming with that vast data, John? Is it looking any good? Let me see it. Let's go over to the computer. Just on you all the time. But I'll tell you, he just had a way of driving you to better research, better results. And it was truly the greatest job I ever had in meteorology, in the sense that I couldn't wait to get to work on a given day. But then I was offered a job of managing the research at National Severe Storms Laboratory in 1986. And I said, you know, I can't pass this up. I just really enjoy the work with the severe storms and so forth. So reluctantly, I left Wisconsin, but it left a wonderful impact on me.
I guess it did. He was quite an inspiring man, that's for sure.
Yeah,
So-
he was.
So he came up against Werner von Braun, didn't he?
Oh, what a story. I think it's the best story in the book.
Well, good. We'll share some of it with us.
He developed a satellite instrument to be launched in the IGY 1957-58. It basically looked like a sphere about 1 foot in diameter, with 3 antennae going out of it, with something about the size of a ping pong ball, painted black at the end of the antenna. The other was painted white, and I think he had another one, I can't remember if it's white or black. But those spheres were spectrometers. They intercepted the radiation both from the sun and from the upwelling radiation, long wave radiation from the Earth. And so he developed these beautiful, beautiful instruments with the help of wonderful engineers. They put it on the satellite, went up, satellite crashed in the Atlantic Ocean. 3 months later, they put it on another satellite. It went up, crashed right on the land launching pad. So 2 instruments went down, and he called them his ping pong anemometers, not anemometers, ping pong radiometers, measured the radiation. And he said, I am going to try it one more time. So in July, they were going to have another one up. He said, I've got to go and clear it with Werner von Braun. So they go down to the Redstone Arsenal. He and his close friend, Bob Parent, a great electrical engineer. They went to Werner von Braun and said, you know, two of these radiometers have failed, and we're hoping the next one will go up. He said, things have changed. And they said, what has changed? I am under so much pressure with so many of these rockets failing. He said, I have a feeling that these antennae with these radiometers at the end of them might be throwing that rocket off balance.
Oh boy.
And Vern said, oh, Werner, you know, he could probably call him by his first. Werner, that can't be. I mean, they don't weigh it. He said, listen, it's not going to go up. Oh, he was devastated. Already 2 had failed. Now they're not going to let the radiometer go up. He and his colleague went back to the motel that night, so depressed, walking around the motel room. He saw a set of fruit, bananas, apples, and oranges in a bowl. And he said, oh my goodness. He grabbed an orange outside of the bowl, cut it in half, went to the mirror in the bathroom and put that orange against the mirror. And this is an experiment I'll tell all of you to perform when you go home. Put that orange, half of an orange, against the mirror, and what do you see? You see a full orange. You see a full orange. And he said, he talked, Bob, I got it. Bob, I've got it. We don't have to use the spheres on the end of antenna. He said, we can use a mirror-backed hemisphere and put it around the belt of the satellite, and Werner von Braun is not going to argue that we're going to foul it up. And with the mirror behind it, all the radiation that comes in, Incident angle of reflection is the angle of reflection. Incident equal, and every radiation beam that hits the mirror will be reflected and hit up into the half of a hemisphere. And I put a little diagram in the book to show that you would get the same amount of radiation into a half of a radiometer on a mirror-backed platform. And he went in the next day to Ferner von Braun and he said, "We've got it, we've got it." And von Braun said, "What do you got?" He said, "We're going to put our radiometers around the belt of the satellite. Every one of them is going to have a mirror behind it, and it's going to be a hemisphere and not a sphere." And von Braun said, "You've got it." And I mean, in the presence of the most famous rocket scientist in the world, he stood toe to toe and convinced him with great on the spot, I would say, insightful thinking. And those are the radiometers that flew for 10 years. Mirror-backed hemispheres instead of spheres on the end of antenna.
John, that's an amazing story. Those moments of genius.
Moments of genius.
Reflect, a kind of intellectual integrity and deep knowledge that's rare. Expound a little more on that in Sumi, what he was about.
Well, I would say an interesting story is what he was working on in his last days. He had heart problems. I don't know if they were genetic. He actually had them when I was working for him. It was going downhill in the 80s, but he never lost sight of a new project. And he basically said, we measured the heat balance in the atmosphere. We've got to figure out how to pull the oceans into it. So he called me into his office one day, and he said, "I've got this idea, John. I'm going to put a little radiometer that looks like a flat plate in the middle of a set of styrofoam circles." He said, "This isn't going to be the final product, but this gives you an idea." He said, "I'm going to put this little plate in there that'll measure the radiation. It'll measure the fluxes coming out of the ocean into the atmosphere." And he said, "We need an instrument, not necessarily on a satellite, but can transmit the information to a satellite." And he said, "This is what I'm going to call my Frisbee flux meter." And he said, "Just imagine it, John. I'm on the deck of a ship, and I've got this little instrument that looks like a little saucer with a instrument right in the middle of it. And I flip that thing out from the deck of the ship into the ocean, and it's going to measure the fluxes to and from the ocean and the radiation from the sun. And now we're going to cover 70% of the Earth that we typically have such a hard time with." I mean, what a great idea. What a great idea. In the waves. I mean, I worked in the ocean. I worked in the Gulf of Mexico. I've seen the waves. I've seen what they do to instruments. The salt cakes on things. It's just unbelievable environment to do measurements. But he said, it's the idea, John. It's the idea. And I said, "Vern, it is the idea." And that was what he was working on to the last days. They actually put some of those Frisbee flux meters out in the Atlantic Ocean, and we're getting some measurements from them. But the atmosphere, the environment of the ocean was so severe, and actually some of the sea life came up and bit through the stuff. And so he basically, on the last day of his life, he called in the director of the Space Science and Engineering Center, Hank Rebercom, wonderful director after Vern left. And he said, "Hank," he said, "we got to get this Frisbee flux meter working." And he said, "I've got to get some more money for it." And he said, "Could you bring me a piece of paper, and on the proposal that's going in tomorrow, I want you to write the following statement." And so at the end of the proposal, he said, "I'm an old man." He said, "I've worked in meteorology and oceanography for so long. I have so much excitement about it, and this instrument is going to help us in the ocean. Make the last days of an old man's life so happy by funding this project." And he did get some funding, but he died a couple of days later. But right up to the last days of his life in the hospital, he was doing his work. He never gave up. And that's the model he set before us. And we all followed him. And after he passed away, and every time I visit there, I just walk around the space science. I say, I remember that room. He had this conversation with me. I was struggling with this project at that time. He'd come in, he'd talk to me. He said, yeah, I can see your problems, John. But he said, look at it this way, dot, 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 dot. And I left with the load lifted off to me. And I just said, I'm going to make this work. He had a way of just infusing you with energy. And that's what came out of that institute. We all had that drive and energy and happiness for working on these projects. And it goes on to this day. He died in 95. So what's that? Almost 25 years ago. You talk to anybody who's in that building and they'll say, the spirit of Vern Sumi lives.
So John, slide over a little bit or move your camera over. You're getting all relaxed there in California like I am, and our television audience wants to see your mug there.
Oh, I was leaning. I'm talking so much that I think I'm getting.
No, we're loving it, and most people listen anyway. But that's great. So talk about a time you ever heard him say fish or cut bait, John.
I never heard him say that, but some of his friends said when he got into the big scientific meetings, especially the international meetings, where the theoreticians like Jules Charney, Ed Lorenz, Joe Smagorinsky, the big powerhouses of what I'd call the theory, some of the Russian leaders, Bugiev, some of those people, he said they'd get going around and round and round. And he said, he'd put his fist on the table, pound it down. And he said, I've heard this, I've heard that. And he said the great thing about it, he understood everything that was going on. He wasn't the greatest theoretician like some of these others, but he basically said, we've got to do something practical and we've got to do it right now. And let's sit down and figure out something to do instead of just talking and blowing wind and fishing or cut bait. But he had a way to do that. He could get mad. He could get mad at the people if they weren't doing the work. And he could take them off to the side and said, if you don't shape up on this, he said, I'm going to put you in a place. I'm not going to fire you, but I'm going to put you in the place where you can't do any harm. And so he took care of his personnel. That was the other thing about space science. Of all the places I've worked, that was a soft money institution. State gave some money, mostly for secretaries and other supporting help, but not the scientists. And I would just say, of all the soft money institutions I've worked for, if money dries up, they just chop. The people go. Not at Space Science and Engineering. There were 5, 6, sometimes 10 or 12 projects. Bob Fox, who was our executive director, he would come around. He said, your project is coming short on money. He said, you're doing good work. We're probably not going to get refunded. He said, I'm going to shift you over to work on Project X since your project is going away. So they kept everybody employed and happy. Never did I see it again, and I may never see it again in the future. It was a place where it was a family, and they took care of you.
We need more of that today, John.
Oh,
absolutely.
Desert Research Institute. Now I'm a visiting scientist, Desert Research Institute. That's a soft money institution. I wish they do the best they can. I don't want to put them down, but I wish they had that luxury of enough projects to move people around. I see people having to leave because their project dried up. And it's a tough environment now. It's truly a tough environment.
So he knew the difficulties of being a professor and doing quality research, and talk about how that led to the Space Science and Engineering Center.
Well, let me read you something. I got my book here. I'm a very good friend of some of the people who wrote about his methods of teaching. And Marty Hurling is now one of the outstanding climate dynamicists in the United States. He works out of NOAA in Boulder. He and I were close friends when he was going through school there. And when I was writing the book, I said, Marty, I know you had courses from Vern Sumi. I've got some information from others. Tell me your thoughts about him. And here's what he wrote. My own recollection of the man from the perspective of a student in the late 1970s who took Professor Sumi's satellite meteorology class was of a person akin to a spark plug, firing on all cylinders all the time with his thoughts, concepts, ideas. For those of us that just wanted to learn the basics, you can imagine a bit of youthful academic frustration. We wanted the mere synthesis that we could be repeated on tests for the sake of a decent grade. Yet, Professor Sumi delivered innovation and forward-looking perspectives, and then delivered tests that seemed to be sketches of his prior evening's thoughts, drafted atop a coffee-stained diner napkin.
There you go.
He was not known as the most ordered, deliberate lecturer, but he gave new, innovative ideas and inspired many. But just like Marty said, when it came time to take a test, it's sort of like, geez, where did he get he must have thought of that last night.
So you mentioned that a Green Bay Packers game played a role in one of his most important ideas. Talk about that for a second.
Yeah, well, he was a Green Bay Packers fan, like all of us who ever lived in Wisconsin were. And on the Sunday afternoon game, he and his son were watching a football game, and they had what he called the playback. I forget the exact term. Here's a play, and now you go through it in slow motion. And he saw that for the first time, and his son told me, he said he just left the football game, went into his room, and just started to think. And he said, how in the world can I use that concept on a satellite? And he said, what I really want to do is I want a satellite that will stay over the same position of the Earth as it travels around, a geostationary satellite. Others had talked about it, but there weren't instruments on them. So he basically said, I've got to put an instrument on a satellite that is staying geostationary relative to the Earth. How do I take a picture of something that's spinning like a Mad Hatter? He said, I can do it in a way that's similar to this replay. He said, I can scan one line at a time, and then as this satellite goes around, I'll put all of these lines together. And I think he ended up with something like 213 lines that then made the photograph, and he made a photograph every 23 minutes on the geostationary satellite. It was called the Spin Scan Camera. He and Bob Parent, his close colleague in electrical engineering, worked on that for years. And then in 1963, they tried it out, and then went on a satellite in 1967, and things were never the same. And in his standard way of saying things, it's not the satellite that moves, it's the weather that's moving below it. In other words, he saw that this instrument was going to follow the weather, like all weathermen want to see weather. They want to see the development of a cyclone. They want to see the development of a mesocyclone. They want to see a collection of cumulonimbus clouds forming and then producing the thunder and lightning and the tornadic storms. How do you follow the evolution? And so that's what he said. It's not the satellite that moves, it's the weather that's moving beneath it.
And now we have GOES 16 and the amazing things we see every day.
GOES was the main thing that came in 1971, and it had the spin scan camera on it, and everything's been developed, incrementally since that time. But I would say the spin scan camera might be considered his greatest achievement, and it have to include Bob Parent, his colleague in electrical engineering, who never quite got enough credit for the work he did. So I told the people who were working on this book, I said, one of my main goals is to give Bob Parent the credit that he deserves, and I don't think he has received it through his work, and he died in the 80s. So I talked to his children and so forth, and they all just were so overjoyed that those of us involved in the project wanted to basically credit their father for their work, because they basically told me, these two men, they slept in the lab all night. They would go to one another's place for breakfast in the morning, teach their classes, and come back and start working in the afternoon. The work ethic was unbelievable, and it was when I was there. The way people worked, they loved their work. They wanted to accomplish their work. I've never seen anything like it, and I'm sure it could be similar to Niels Bohr quantum mechanics lab in Copenhagen or something, where the excitement was so great. And I think in geophysical science, there probably never was a place that was any more exciting, maybe equal to it, but never more exciting.
When I was in high school and in college, the university that I went to, Sanford University in Birmingham, used to invite Dr. Edward Teller.
Oh yeah.
To come and speak, and we would get to have lunch with him. And the things that you're talking about tonight remind me of those opportunities that we had to talk to Dr. Teller.
Oh, that would have been wonderful. I wish I could have been in some of those meetings, Bill. I heard others tell me about speeches that Teller gave, and even though he had quite a few critics in the physics community, especially when he was pushing the H-bomb, he was a brilliant man, and he knew how to excite those around him.
He did. He was a very inspirational man too. I've just hogged the conversation tonight. Kim, I know Brian, I know you guys want to
it's fascinating.
Something. It really is a fascinating conversation. Kim, anything you want to ask or add?
Oh, no, I think this has been an amazing conversation. The only thing I've been possibly thinking to ask is, in those formative years that they were working on developing satellite technologies, what were some of the first major thrusts of the science as that was coming along? What were some of the big problems that they were trying to tackle? You covered a couple here and there, but I'm really interested in when it all started. What were these really great frontiers they were all so excited to pursue together?
I would say throughout the decades from the 60s, 70s, 80s, and even into the 90s, Verne realized that to get the most accurate measurements of the radiation in the Earth's atmosphere, that he is really after the balance, the imbalances of the radiation. More solar radiation coming in the equatorial latitudes compared to the outgoing radiation. You have a surplus there. You have a deficit beyond 30 or 35 degrees in both hemispheres. And so he wanted to know, based on accurate radiation measurements, then what would have to happen in the oceans and atmosphere to keep the equilibrium. So he's really hitting on what I would say the key issues in climate today. And he just said, I've got to keep making these instruments better and better and better. And not only just for the heat, he said, we need to know the temperatures in the atmosphere. And so he brought people along who then could look at the different gases in the atmosphere and the radiation that was received at the satellites and break that down into the temperatures in the atmosphere. And even to this day, the biggest deficit of satellite meteorology is, unlike the radiosonde that can give us temperatures sometimes every 10 meters in some of our latest instruments, 10 meters, 20 meters, whatever, all the way up to the tropopause, from a satellite, because you don't have enough information on the shortwave wavelengths that are producing the radiation. You have poor resolution. Even now, I would say the best resolution we can get is probably things like 100 meters, every 100 meters. And so in a severe storm environment where you want to look at the lapse rates and get details on the temperature and moisture structure, you can't get that from the satellites. And so now Bill Smith and a lot of the other people that work with Verne, they have what they call hyperspectral methods to use many of the wavelengths within the various gases in the atmosphere to try to get that resolution better and better and better. So that, I would say, those problems, the goals were the same. The instruments had to be improved. And then the other thing that came along was, once he got the geostationary satellite, he said, we've got to be able to use the satellite to get winds. Well, he basically said cloud motions are something like the winds. They're not exactly the winds, but clouds move with the winds. So how can we then use a satellite to take sequential pictures from a geostationary satellite and look at the movement of cloud elements, and from them determine wind speeds? And to this day, Chris Veldon at Space Science and Engineering Center, many publications, many international projects, he's just producing winds that are unbelievable over the ocean structure, Are they perfectly accurate? Or is they as good as radiosondes? No. But they give a structure that's very accurate. And those winds can be put into our big models now. And they're really helping the forecasts of all the elements, including the rain and whatever. So I would say, to answer your question, it wasn't, the challenges stayed somewhat the same through his life. But the instruments and how you put them on a satellite, like that spin scan camera, my God, the work and the hours and the engineers and everything that went into creating that camera. We're talking decades and intense work every day by not 2 people, 3 people, 20, 30 people. So I would say some of the challenges that we had right at the beginning, they're still there today. And now climate, of course, is a huge issue. So I would say the radiation balance and getting very accurate measurements of the incoming radiation as a function of latitude and longitude and the outgoing radiation, and then looking at those imbalances, putting them into climate models, that is what I would say is the key. And we're not going to do it in any other way except with satellites. So the instruments have to get better. So when you talk to the people in space science and engineering, it isn't just the meteorology. They always talk about the instruments. So it's kind of like theory and experiment going together. And that's what I loved about it. I just felt like I was in a physics laboratory. We know the theory, we're reading about the theory, we have theoreticians, but how do you do it? And that's when he said fish or cut bait. He was basically saying, let's make sure that we get something going. And then it's sort of like, let's take a step in that direction. Maybe it isn't perfect. We're going to learn something. We're going to do something following it. He didn't want to sit around and hee-haw and hum and make poetic statements. Let's do it. Let's do it. And that's what I brought away from my time at Space Science. And I even tell my students, I said, I know you don't know the result. Get in there just like you're in a garden. Get your hands down in the dirt and see how the roots are doing. Don't sit around and just pour some water on it. Get down in the dirt and work. And that's what Vern always said. Get down there and start working and work hard.
Yeah. Wow, that is just incredible.
That's a show title too. Get down in the dirt and work.
Good question, though. I appreciate it.
Hey, John, you've been on here for more than an hour. Just real quick, before you go, I just wanted your thoughts on the state of meteorology today. A lot of us are getting ready to retire.
Yes.
And what are your thoughts on the new generation coming up and the future of the science?
Well, I just saw the results of a seminar held at the European Center for Medium Range Forecasting, which in my opinion is the best national, or that's a NATO organization that produces the best global forecasts every day. Not that our own center is very good, the Navy's center is very good, but ECMWF, in my opinion, is the best. They just had a seminar, and they basically they said, what do you think? Here were some of the questions. How many pieces of information went into a weather forecast from our barotropic model in 1955 over the United States? How many pieces of information? The grid spaces were 200 kilometers apart. There was about 12 of them in the north-south direction. There was about 15 in the other direction. So we do the multiplication. There are about maybe 300, 400 pieces of information. What do you put in there? You put in the geopotential and that old model of you could just use geopotential and you would use geostrophic winds, whatever. 300 pieces of information. What came out of this seminar? They said, do you have any idea of how many pieces of information go into our model today? Every 12 hours. Well, first of all, think of this. What is the grid spacing around the globe? 15 kilometers around the globe. How many levels in the vertical? 33. How many pieces of information do you need at every one of those grid points? You need the winds, the 2 wind components, not the vertical velocity. We've never been able to measure that one. The U and V components, the temperature, the pressure, a moisture variable at every one of those points. From 300 in 1955, we now have 1 followed by 9 zeros. Every
Wow.
every 12 hours. And that's what allows us to do data assimilation. That's my field. Data, using all that information with the dynamical model to get them to cooperate and understand each other, put that into the model and let it fly. But they said our major effort is going to be developing a sea ice air model over the poles. And we think by putting the details of ice into our model, albedo, reflection off of ice, what is the temperature of the air next to the ice, getting that information. They feel that by incorporating that into their existing model, they are hopeful that they are going to be able to make meaningful 30-day forecasts. And I sat there and listened, and I read it all, and I said, you know, what a wonderful goal. My own experience tells me maybe you'll get to 15 days. I don't know if you'll get to 30. But that's the kind of effort that's being made around the world now. And I truly would say that what we do need in meteorology that I don't see enough of, we see these generalists. We need the generalists who think about the whole atmosphere as three-dimensionality. And, you know, I knew Colonel Robert Miller. Maybe some of you heard that. Air Force severe storm meteorologist. I knew Bob Miller. This man, of all the people I've ever known, theoreticians, practical people, experimentalists, he had a three-dimensional picture of the atmosphere like nobody ever had. He saw the winds. He saw the jet streams interacting. He saw the structure of the low-level moisture and temperatures interacting all three-dimensionally. And that man, to this day, is at Storm Prediction Center in Norman, our center for severe storm forecasting. 5 outstanding forecasters, a couple of them are my students. The Storm Prediction Center still, after his 1948 ideas, still using his thoughts on the three-dimensionality of the atmosphere. So we need people who think three-dimensionally, not so much theoreticians. I think some of the great synopticians of my lifetime in meteorology, I think Fred Sanders at MIT was one of the greatest. He trained so many outstanding meteorologists. He worked on hurricanes, hurricane tracking, jet streams, rainy situations. He trained people to look at the entire atmosphere. And what I see a little bit too much of, this focusing. Somebody comes out with their PhD. What did you work on? I worked on the microphysics of a particular type of cumulus cloud. I'm not saying that isn't important. That work has to kind of continue. But we need somebody, more than one, to have this larger generalist attitude. And I don't see them being produced on our institutions. And so that, I would say, is my greatest concern. And we need them because they did so much for us. I think Tor Bergeron was the best of them all in the 20th century. He was the Norwegian synoptic meteorologist. He basically pushed forward the Bergen School polar front theory and taught us all about it. But it was interesting, when numerical weather prediction came along, they asked Tor Bergeron, what do you think about doing all this stuff in a computer instead of kind of taking all the information in the 3 dimensions of the atmosphere and whatever? And he said, you know, I don't think it's going to work. And he stuck with it. And after about, I think, 10 years or so, he said, I think it will work. But then he said, this data assimilation idea of taking all the different kinds of data, the satellite data, the radiosonde data, the buoy data over the ocean, trying to bring this together to get the complete picture of the atmosphere and blending it with the model. He said, you know, and this was near his death, he said, I'm pretty sure they're never going to get that right. And it's because of the way he thought about the atmosphere three-dimensionally. Can you get a machine to do it? Can you get equations to do it? He said, maybe not. And that's why I say, along with the theory and so forth, you need these other people, the Tor Bergerons, the Fred Sanders, the whatever, to kind of give us this expansive view. And we're not producing enough of them now. I don't see them at the meetings. I go to the meetings and I listen to the talks. They're so narrowly focused. And in a way, they really maybe understand that process very well. But, you know, the other thing that Tor Bergeron said in one of his final articles, he said, I worked with Wilhelm Bjerknes. He said, I worked with Carl Rossby. I worked with other theoreticians. He said, the great thing about those two theoreticians, they really saw the atmosphere in its basic physical theory. But he said they never lost sight of the practical problem of weather forecasting. And I think that is something for us to keep in mind. We can get into theory, we can get into equations, we can get into computers. This is like the human body. It's a very complex system. And even, I think, in the medical profession, some of those diagnosticians who may not know as much about the heart as some specialists, those people that know how the whole system works, they're so valuable. And we don't have enough of them.
Yeah, it's like mechanics working on a car. They see the whole thing.
That's right, especially today with all the computers.
Yeah, exactly. Well, goodness, this has been fantastic, John. I mean, I wish I've got 15 more questions, but we've got to wrap the show up. I mean, it's like the stories have been just fascinating to hear tonight, John. So I hope you come back sometime. You've given us more than an hour, but you're very kind to do this. And goodness, it's been great having you on the show.
Thank you for the opportunity. I don't usually have a chance to talk about such a wide range of issues, and you're such good examiners. And really, I just felt I had an audience that just was pushing me to better explanation. So it was a pleasure, and wish you well in your future podcast.
Awesome. Well, John, thank you so much, John. Have a great week, and I hope we didn't keep you up too late tonight. Thank you.
Thanks, John.
Bye.
Wow. That was awesome.
That was amazing.
It's like I didn't want to stop, but yeah,
great.
No. I just wanted to ask him all kind of questions, but we've got to move on here, and I am the lead on the newscast in here tonight, so we're going to roll. Professor Peters and Tony Rice in the astronomy report will come back with the weather roundup, the picks of the week, and much more. And Bill Murray, you're going to be the guest host here because I got to go change clothes and go to work. As WeatherBrains rolls along, y'all hang in there.
WeatherBrains 101 with Professor Peters.
A quick glance at your calendar, and you'll note that the United States is away from the start of the 2018 hurricane season in the Atlantic Basin. Before that date, I guess no one told them when the official start of the hurricane season actually is. In fact, the National Hurricane Center is currently showers and thunderstorms extending from western Cuba across the southeastern Gulf of Mexico, the Florida Straits, and much of the Florida Peninsula. This area of concern is associated with a broad surface low and trough interacting with an upper level low. This system could acquire some subtropical or tropical characteristics while it moves slowly northward across the eastern Gulf of Mexico during the next few days. Regardless of subtropical or tropical cyclone formation, the system will enhance rainfall across portions of Florida and the northeastern Gulf of Mexico during the next few days, where rainfall amounts could range from 2.5 inches along the Alabama-Georgia line to as much as 8 inches just offshore from Melbourne over the next week. As most weather nerds know, NHC works from a 6-year list of hurricane names established by an international committee of the World Meteorological Organization. Should the system currently under scrutiny become organized enough to be named, it would be called Alberto. Other names on the list include Beryl, Chris, Debbie, Ernesto, Florence, Gordon, Helene, Isaac, Joyce, Kirk. I wonder if that's for Captain Kirk. Leslie, Michael, Nadine, Oscar, Patty, Raphael, Sarah, Tony, Valerie, and William. This is the same list that was used in 2012. Sandy was on that list, and it's the only storm that occurred in 2012 that was retired. If you have a question about the weather, drop an email to question@weatherbrains.com.
Looking beyond the atmosphere, here's Tony Rice with your Astronomy Outlook.
Earlier this month, the West Coast got a pre-dawn treat with the launch of the Mars-bound InSight mission from Vandenberg Air Force Base. This week, it's the East Coast turn. WeatherBrains listeners along the mid-Atlantic states from Connecticut down to South Carolina and as far west as maybe West Virginia can see the launch of an orbital ATK Antares rocket lifting OA-9, a cargo resupply mission from the Wallops Flight Facility on Virginia's eastern shore. The Cygnus spacecraft will carry over 3 metric tons of cargo bound for the International Space Station. Liftoff is scheduled for 5:04 a.m. Sunday, May 20th. And this is before sunrise for all of the viewing area and before twilight for most of it. So that flame from the 2 RD-181 engines powering that first stage should be visible, weather permitting of course, for hundreds of miles away as it rises on a southwestern trajectory. But unless you're on Virginia's eastern shore, you probably won't see much of it right at 5:04 a.m. The launch will be hidden by the curvature of the Earth. To figure out which direction to look and when to expect the rocket to rise above your horizon, visit sites.wff.nasa.gov/WMSC. When you visit on a smartphone, click on the arrows at the bottom of the screen for a compass which will turn green when you're pointing in the right direction to see the launch. Now, while you wait for that rocket to appear above the horizon, look to the northwest, and you'll see its destination, the International Space Station, passing overhead. Any ISS-bound launch, about 90 minutes before sunrise, will be preceded by a pass of the International Space Station, and Sunday is no different. The station will fly directly over the launch pad about 3 minutes after the scheduled launch. This is why, should weather or any other reason postpone the launch, the next try is generally the following day, about 22 to 23 hours later. This ensures that the launch pad and the station are lined up sufficiently so the spacecraft can catch up. That's your Astronomy Outlook. Follow me at RTP Hokie for more spacey stuff like this.
Thank you, Tony Rice, for the astronomy report. Thank you, Brian Peters, for the Professor Peters segment. Always a fascinating one. Brian, tonight was like having a guest lecturer, more than a guest weather brain. Who are some of the professors from your academic range?
Dr. Noel Lesueur.
Tell us a little bit about it.
Well, he was really big into tropical meteorology. And a great story. He was also, unfortunately, a smoker. And you remember the old fax maps, right?
Oh, yeah.
You remember that they came out wet, but they dried.
Smelled
and
funny.
They became tinder dry. Well, he was giving a map briefing, and he had the cigarette behind him, in his fingers, and he set the map wall on fire.
Oh, my goodness.
Anyway, also another one that was big at Florida State when I was there was Dr. Seymour Hess, who he was very involved with getting measurement equipment on the satellites or the spaceships that went to Mars. That was one of his big things. So
that instrumentation, as we talked about tonight, is so important. Kim, I know you've had a lot of time with Dr. Brooks and a lot of other people. Do you have any stories you can share, or would we be sworn to silence?
Stories to share just from folks at the lab?
Yeah, anybody who's been inspirational in your career. I know there have been a million, but
yeah, I mean, that's the tough thing is I've been so fortunate to have wonderful, inspirational folks in my sphere. I'll share a really quick story that's just really funny of Dr. Brooks, Harold Brooks. Something I found in memory folders from my first interaction with Harold. I found my REU folder going through my garage the other day, and I had some Post-it notes. I would write down quotes, funny quotes that people would say, and Harold was, I think, the first feature. He was many features of this, but when I was doing my REU project, he had teamed up with an economist. It was the first time the lab had been interested in trying to do, or had the ability to put forward a social science research project for a student, and I got to do it. And within a month, I had shown that the method they thought that they could use wasn't going to work. And so I'd done a tremendous amount of work in a short period of time. And really quickly after that, our apartment at the University of Oklahoma was infested with brown recluse spiders. And I got bitten twice, which was exciting. And Harold, always one to give encouragement and to be there for you, told me, if I did die, he wanted to make sure that he got all of my files from all of my work so that he could publish it. And they would be sure to include me, in memoriam as another author on the paper. And I was a student for all of a month at this point. I was an undergraduate. No, I was just like, well, this is, and he has remained true to form. That is the spirit of Harold Brooks. He's there for you, and just always has such a sharp mind and enormous enthusiasm. He reminds me a great deal of John Lewis in his ability to bend your ear, tell a story, talk about the history behind anything really. It's sort of a trade. His history of science is just sort of a trade interest for him, and it's delightful to be around those people.
Well, I forget where I asked him to breakfast at one of the conferences, and it was an experience like, having, John Lewis on just now, where literally I learned so much in the course of an hour over some buttermilk pancakes that, that friendship still, is incredible today. And where is Harold from? Do you know?
Originally? He's originally from, sorry, go ahead.
You say.
Well, he was originally from St. Louis.
Exactly. So he told me the greatest place to eat on the hill in St. Louis, and I'm really excited that we're going back there for the NWA. And he is going to deliver a talk on the big tornadoes that have hit St. Louis on that Saturday at the WeatherFest, because this is the 25th anniversary of the Great Flood, but also there have been, of course, incredible tornadoes that have hit St. Louis too.
Yeah, there have been some incredible ones. He actually, in my RU year, when I was looking at economic impacts of tornadoes, he had me do some archival research on the St. Louis tornadoes, historical tornadoes, try to find some information about those. And the Missouri Historical Society just was delighted to have those inquiries. But the downtown had been destroyed many times over the course of the early 20th century. So that'll be a great talk for sure.
It will be. It's going to be a great time. So I guess it's time for the weather roundup. Brian Peters, did you get a record high at your house today?
Well, I don't really have records going back that high, but I think it's amazing.
I thought they went back
did. But then again, when I saw that the record high for today was only 92 until today, I was amazed. I just would have thought it would have been higher.
Yeah, because the last several days they've been 94, 95, and relatively low. But I thought it was interesting that I think it's 2 to 7% of the days in this 1 week period have had highs in the 90s in Birmingham. And so this is a fairly rare occurrence for us, for sure. So how's the weather in Oklahoma, Kim?
Wonderful and about to get better. I've been monitoring the development of convective line that's coming at us from West Texas, from the Texas Panhandle. So we should be getting some rain. It looks like everything has diminished in intensity, but when we get rain, it's a wonderful day. So we're pretty excited about that. And, for what looked last week like it was going to be a pretty ho-hum week for some of our test bed participants, the visitors who are coming in. People come here in May expecting to have a certain Oklahoma experience, and it doesn't always happen. This year, it may really not happen for a lot of people if models hold true. But at least we can give you some good rain. So happy to be able to offer that to our visiting folks.
So when you do the test bed, you can go anywhere in the country, though, can't you? So would y'all study like the Mid-Atlantic today with that storm coming in?
Yeah, so I think the folks on the forecasting side of the test bed, I've been working with emergency managers on the warning side. So we're testing some new warning technologies on the longer range desks where they do work with, say, the Storm Prediction Center scale, time and space and time scale of information. They studied today, I think their area of focus was actually here and up into Kansas. If you look at, I was looking at the experimental modern forecast modeling system, and I'm pretty sure that's their domain today, which I was interested by. The choice wasn't the derecho potential of the Northeast, but we do have the ability to go anywhere that weather is. And so last week we had in the test bed for our emergency managers experiment, we had a guy from Wyoming, which was delightful. And Wyoming was a focus of severe weather several of the days. So we would go in and join their weather briefings, and this county emergency manager from Wyoming got to see this personalized forecast from the top scholars and practitioners in the world in severe weather. It was a real treat. So yeah, we go wherever the weather is where the folks in that forecasting side will take people.
Mm-hmm. And some of the most interesting weather is in the Gulf of Mexico right now, Brian Peters, in our backyard. Are the hurricane hunters still flying into that system tomorrow? Do you know?
I have not seen anything since late this afternoon. I had a meeting to attend, and just before WeatherBrains, so I haven't seen anything. So I was also amazed, Bill, since you're in the weather history business, about the 36-mile long tornado track back on May 4th up in New Hampshire.
Oh my goodness! I don't think I even heard about this. Brian, tell us more.
Well, it was a tweet from the guys up at Gray, Maine, and it was a confirmation of an EF1 tornado with winds 80 to 100 miles an hour that touched down. And this again is back in early May 4th, from Charleston, New Hampshire, and tracked 36 miles to the east-northeast before lifting off in Webster, New Hampshire. Don't know anything about fatalities, but they gave it an EF1 strength. And I don't think there were any fatalities, but not quite sure of that. But anyway, I think, that's back up in the neck of the woods where I was born. And I think 36 miles, that's pretty spectacular.
Wow. Yeah, we'll have to check in with our friend, Dr. Lourdes Aviles up at Plymouth State University, and see if thing came close to her house. That's up in her neck of the woods. So, Brian, will this thing be named, you think?
Oh, I think it's kind of touch and go. I'm just not quite sure.
Yeah, well, I went back and looked. I think there have been 40 systems since 1900 in May, and one hurricane has hit the United States during that time. So
that sounds about right. Yeah.
Hurricane
and it's funny that you should do that, because my pick of the week is right up that alley.
Oh, there we go. Good. All right. Anything else, Kim, to add to the weather roundup?
Nope. I think that'll do it here.
Yeah, I think that covers us right there. Look, one tornado warning in southern Kansas right now. It looks like.
Yeah, and it's been persistent. It's been warned for what feels like 2 hours.
That looks like where I saw my second set of tornadoes back in 2004, I believe it was.
Really?
Harper County, Kansas.
Yeah. Those were your first tornadoes. Those were my first tornadoes.
Were they really? I actually saw one the month before in Petrolia, Texas. But this event in southern Kansas, that end of May 2004, was like the Super Bowl of tornadoes. I think we saw 11 tornadoes in 2 hours.
Yeah.
And other than going with John Olshew, Brian Peters, one time, I haven't storm chased since, because it was like going to the Super Bowl.
Yeah. Well, you don't need to with that success rate.
Yeah. So we went, I think, Brian, John and I went in 2006 or 7 up to Northwest Alabama. And, there was a big high risk day. And of course, it got too hot, and, the LCLs got too high, but one storm came out of Mississippi. And, I know you experience this all the time, Brian, but I was amazed at how much law enforcement we could attract with just with just a storm chasing vehicle.
Yeah.
And the Alabama State Troopers went and moved or blocked, I think it's Highway 43 maybe, that's coming down from the Shoals down to Tuscaloosa, went and blocked off like a 5-mile stretch of US 43 based on what we were seeing, on my that radar that I won, the old Baron radar, at the Chaser Con back then. So that was a fun experience, getting law enforcement to do your bidding. So I guess it's time for picks of the week, guys. Kim, we'll start with you. What have you got?
Sure thing. So I'm going to use the article I was going to use last week before I feel like I slept through class. I'm so sorry, guys. It's like one of those college nightmares. But I had this article that was hot off the presses last week, still pretty fresh news. It's from the American Institute of Physics, which is an affiliate of the American Meteorological Society, as many of you know. And the article is about the frontier of space weather. So Congress now, in the wake of the weather bill that was just passed that deals with topics in forecasting for severe convective weather, for hurricanes, and some other topics, they're now turning their attention to space weather. And they note in the article, they do a really good, pretty good job providing an overview of sort of the very early stages that science is in and what they're doing to foster technological growth in the area. And it's this really fascinating story of private sector and public sector and who owns what. There are a lot of private assets in the upper atmosphere that could benefit from better forecasts. And the private sector, unfortunately, gathers a lot of data that's proprietary. So data sharing is a challenge. So it just read on the really great debates going on both sides of the aisle about, well, how do we define the swimming lanes for all these different partners and try to advance the observations and forecasting technologies in that part of our atmosphere.
Outstanding. What a great pick of the week. Thank you, Kim. So glad you could be with us tonight. It was quite a treat to have our guest. Brian Peters, what's your pick of the week?
I was looking up some, we're coming up on hurricane season, and I was looking at some of my links, and I went to one that I had, I think I've actually used before. It's historical hurricane tracks from the National Hurricane Center, and I don't know if it's just been very recently or not, but it seems to me that their webpage is really a lot better. It's been updated or whatever. So I'm going to use that as my pick, and it was fun to put in Birmingham, Alabama, and see that since the 1900s, early 1900s, we've had a lot of storms come by us. It's amazing.
What was the storm that dumped all the heavy rain and broke our rainfall record? Was it 1916, Brian?
Well, Ivan broke the Ivan in 2004.
For a long time was, yeah. But
yeah. I'm not much into all the details of those that far back.
But that was an amazing day, though. The day that Hurricane Ivan came to Birmingham. That was,
yes, it was
quite an amazing day. Well, that's great, Brian. Thank you. And we'll keep in the hurricane vein the next couple of weeks. Well, actually, we have a fun show next week. Tim Vasquez, who you all know, who does a really good weather briefing every night on YouTube. We're going to marry the two shows together. So the show next Monday night will be his show and our show together. So, come with lots of weather insight into all the features next week, because we'll kind of be walking along with him as he does that. I'm really excited about that. And then the week after that, we'll get together with Brian Norcross and Max Mayfield and talk hurricanes at that point. And we'll continue that conversation to the first week of June. We'll have the new director of the National Hurricane Center, Ken Graham, who I am really, really excited about having on the show. And we're booked out through the end of September now. I don't know what the deal is. The listeners and the audience just keep sending these great guest suggestions. And,
fabulous.
So now, if you want to get in on WeatherBrains, you'll have to be out in October. I can't even think out to October, Brian Peters. Oh my goodness! But my pick of the week is the Inside the Eye blog from the National Hurricane Center. A great article this week on why people who work in hurricanes have flood insurance, and I think that's an important lesson. I went to my insurance agent, our checkup, the old discount double check thing, or whatever. I expected Aaron Rodgers to show up, but I asked, do I need flood insurance? The first answer out of his mouth was, no, you do not need flood insurance. You do not live in a flood zone. I was like, wrong answer. And they're still struggling to get me a rate for flood insurance, at my house, which is really surprising. So, anyway, that's my pick of the week. We all need to be beating that drum. So, any further business, lady and gentlemen?
That'll do it.
Well, it's been a long show, but it was certainly well worth it.
It's a wrap. Really
enjoyed having John on the show. But this is WeatherBrains Weekly Netcast. It's all about weather.
we love doing this. We've been doing it forever. I think we're in the sunset of our career, Brian Peters. You know, he was like, I think John wished us good luck on our podcasting career. I'm like, we've been there and done that.
Yeah, I did the math there, Bill. And between John and I, we have about 110 years in the weather business. That's not a good sign.
That is awesome. But his stories were so cool and enlightening. I enjoyed it very much. But until next week, when we'll join forces with Tim Vasquez, the whole WeatherBrains crew. I hope you have a great week, and we'll see you next Monday night.
Good night.
Good night.
Bye. Thank y'all.
And there's always a few people still watching. Wow. Boy, that was great. Very fascinating show tonight. Great to have John on the show with us, but I've got to go do some weather back in here. So thank you guys for watching. Y'all have a great week. We'll see y'all next Monday night. Can't catch us over on Song of the Night on my Twitter feed at Span. That'll be coming up in about 10 minutes. See y'all shortly. Y'all have a great week, and God bless. Bye-bye.